Okay. Let's try a couple examples here. And I think today I might put you into breakout rooms too. For example, here we go. Prove or disprove. For all x living in the integers, x plus 1 quantity squared is equal to x squared plus 1. For all x living in the integers, x plus 1 quantity squared equals x squared plus 1. Stare at that for a second. Decide if you want this to be true or false. So we're going to go thumbs up, thumbs down. Do we want this to be true or do we want this to be false? And that will decide the process that we need in order to prove this. So thumbs up or thumbs down, true or false? What do we got? True or false? True or false? Everybody's saying false. Okay, so we are going to, I'm going to label this proof, but we're going to say disprove. So you do also want to tell me whether you're proving something to be true or whether you're disproving. All right, so then I need to come up with a counterexample. So let x equal, hold up fingers. First person to hold up fingers is going to get their counterexample. What do we want? Counterexample, x equals what for an integer? Somebody give me fingers. X equals Grant 2. Okay, so let x equals 2. That's our first step. We found a counterexample, and then we have to show that our counterexample works. So here's what has to happen for our counterexample to work. This first part has to be true. X has to be an integer, which it is. So then x lives in the integers. And the second part here has to be false. And also we'll say but x plus 1 squared is equal to 2 plus 1 squared, which is 3 squared, which is 9. And x squared plus 1 is 2 squared, which is 1, which is 5. Not quite done, because we're going to assume that the reader totally needs their hand held all the way through the proof. So you have to say x squared equals 5, but 9 is not equal to 5. So you gotta make it clear, absolutely, positively clear as clear can be why your counterexample works. I am going to get crabby if you stop at this point here with equals 5. You gotta tell me why your counterexample works. In this case, these two things are supposed to be equal to each other. So therefore, you have to tell me explicitly that these two things are not equal to each other. Am I being clear? Yes? Okay. You can take some of the work out if you wanted to. You wouldn't have to write out all of these intermediate steps here and this intermediate step there. You can do basic math in your head. That is fine. But I do want you to be very clear about things not being equal to each other. Okay, so in order to conclude here, therefore, we can say the statement is false. And we'll go with an as desired for this one also, because I said disprove at the beginning, so that was my as desired. That was what I was trying to come up with. So we can say as desired to finish these if you want. Disproof of existentially universally quantified statements, disproof of universally quantified statements is not as highly structured as some of the other proofs that we've been doing all semester. So you maybe have a little bit more freedom in here. You're not necessarily going to have the same wording every single time. That's okay. And so when I'm doing examples, I might not necessarily have the same wording every single time. I'll try, but these are just a little bit less structured. They're kind of sort of like proof by contradiction in that you wander around until you find a problem. The nice part here is that the problem is way more obvious once you pick your counterexample. So let me have you guys work on one on your own, and then we're gonna do implication. So let me have you do this one quick. For example, prove or disprove. For all n living in the natural numbers, n squared plus 4n plus 1 is prime. So prove or disprove on that one. For all n living in the natural numbers, n squared plus 4n plus 1 is prime. And remember, natural numbers are the positive integers, so they start with 1. Decide if you want to prove or disprove this. It's in section 9.1, so it's probably a disprove, but you know, it could be proof. It's possible. And then see if you can come up with a counterexample. Okay, my counterexample was n equals 1. That was the one that I used. Did other people have different counterexamples? Anybody else have a different counterexample that they used? Yes, no, maybe, no, no, no. Okay, all right. There are different counterexamples. So does n equals 2 work? That would be 4 plus 8 plus 1. It does not. N equals 3. 9 plus 12 plus 1. I think n equals 3 is going to work. So you could use n equals 3 for a counterexample, etc., whatever you want to use there. But here's my counterexample, n equals 1. These should remind you a lot of the proofs of existence statements, right? We did that way at the end of chapter 7. So these are super similar to the proofs of existence statements. It's just a disproof by counterexample instead of a proof by example. So that's what these should look very familiar to. Any questions on this one before we do a proof of an implication? Anybody here? Doing good? Okay, let's do an implication then. So how about this one? For example, prove or disprove. For all a and b living in the integers, if a squared equals b squared, then a equals b. For all a and b living in the integers, if a squared equals b squared, then a equals b. Sorry, my squareds are a little messy here. If a squared equals b squared, then a equals b. So again, we're in this section. We are going to probably do a disproof. So disprove. All right, so we need to let a equal something and b equals something. And then we're going to say then a and b live in the integers. That needs to happen. We need to make sure we pick integers. And a squared is equal to b squared. I need to have my hypothesis being true, right? So I need to have a squared equals b squared, but a is not equal to b. So I need to have my hypothesis be true and my conclusion be false. What do you want? Somebody volunteer. You might have to do this with microphone. It's not going to work so well with fingers necessarily. For a and b, give me values for a and b so that a squared equals b squared, but a is not equal to b. What do you got? Somebody be brave, volunteer. What do you got? Go ahead, Josh. A equals?
A equals 1.
Okay.
B equals -1.
Cool. A equals 1 and B equals -1. Then A and B are in the integers, and A squared equals B squared equals 1, right? I should probably put that in, but A is not equal to B because 1 is not equal to -1. So I need to make sure to have my hypothesis true and my conclusion false, right? I want the whole implication to be false. Think about your truth table. The only way the whole implication is false is if the hypothesis is true and the conclusion is false. So I want to have that whole implication false. And then we can say, therefore, the statement is false as desired. Good. Smiley face. Questions on that one? Anything? Doing good? Okay, I'm gonna give you 2 examples that I want you to work on in breakout rooms. So 2 examples here, and both of these are prove or disprove. Here's the first one, prove or disprove. For all X, Y, and Z living in the real numbers, if X is greater than Y, then X times Z is greater than Y times Z. That's your first one. For all X, Y, and Z living in the real numbers, if X is greater than Y, then X times Z is greater than Y times Z. And then here's my second one, prove or disprove. For all sets A, B, and C, A intersect B union C is equal to A intersect B union C. For all sets A, B, and C, A intersect, in parentheses, B union C equals, in parentheses, A intersect B union C. So think about what your counterexample is going to have to look like for the second one, right? We're talking about for all sets A, B, and C. So for the second one, your counterexample is going to look like A equals something, B equals something, and C equals something. You're going to need to come up with 3 sets for your counterexample because my statement is dealing with sets. For your first one, all of these are real numbers. So that's where you're going to go for your counterexample. Okay, everybody got these down? Ready to do breakout rooms? Yes, I'm just totally going to assign you randomly. We'll do 2 rooms. Okay, there you go. You should have gotten an invite. Go do breakout rooms, and I'll pop in a couple minutes and see how it's going.